I usually give it just a little bit. Alright, so here's the last video. It should be shorter of me going over some of the examples. So I pulled up number 22, and well, you can see it right there on the left, but I'll go ahead and write it down as well. So remember, you have two options on these types of things. You can pull up Desmos and graph them and just see where the graph touches the x-axis, or you can factor them and set the factors equal to 0. Your choice on how you want to do that. Okay, so this one, for example, I'm just going to go ahead and set them equal to 0. So x plus 5 is equal to 0, and then the other one would be x minus 1 is equal to 0. Subtract 5 from both sides, and I get negative 5. And on the other one, add 1 to both sides, I get 1. So my answers are going to be 1 and negative 5. Okay, so you put them in. I'm just going to assume that I got it correct there. I guess I can peek at the... Oh no, the answers are on the back of the book. So I don't want to make any silly mistakes here, so why don't I just go ahead and do it. So 1 and negative 5. Check answer, and they're good. All right, so moving on to that next one here. So on 24, this is one where, you know, I don't know, you might want to graph this. It depends on if you want to do the x factor or not. Some people like it because it's kind of like a puzzle. So you'd have something like this right here. Notice I can't just look at that and say what the intercepts are. So I would have to do my x factor. The number on the end goes on the top, and the number in the middle goes on the bottom. Now, it has to add to a negative, but multiply to a positive. So really you have to go with things like negative 1, negative 52, negative 2, negative 26. I know 3 doesn't go into 52, but 4 does. And that's going to be my choice right there. So negative 4 and negative 13. Now that's not my answer though, because x minus 13. So remember my same trick from before. You could think of them as the opposite of what it looks like, or set them equal to 0. So you would get a 4, and on the other one, x minus 13 is equal to 0. So x is equal to positive 13. Okay, so 22 and 24. So 26, I think is kind of a normal one. So, oh yeah, okay. So I'll do 26, and we've got on that one g of x is equal to negative 4x. And then I've got minus 8x minus 4. This is kind of like the one that I did in the example in the notes before, because I can factor out a GCF. Negative 4 goes into all of those. And I forgot a little 2 right there. So negative 4 gets divided out. So I get up with x squared, and then I'd have a plus 2 and a plus 1. Okay? Now, if I just want the zeros, I really can forget the negative 4. If I'm graphing, I can't forget the negative 4. It does change things. But for us, 1 goes on the top, 2 is on the bottom. There's only one choice here. It's 1 times 1 is 1, and 1 plus 1 is 2. So that turns into g of x is equal to negative 4, and then we're going to get x plus 1 squared. So there's only one of them. So x plus 1 is equal to 0, so x is equal to negative 1. Now, what does it mean if there's only one x-intercept? Well, what's going to happen is, why don't I just sketch this in? What's going to happen is you're going to have a parabola, and I do know that this one was going to go down because that was the a is negative 4, but because there's only one, that means that's also going to be my vertex. So there's negative 1 right here. and I know it's going to open down. Obviously, this is a sketch. I don't know about any of the other points, but I know that that's where it's touching the x-axis. So that's -1, 0. Okay. Now the last two are kind of interesting because they are not going to be parabolas. So I think I want to do them. Maybe I'll graph them both, but I'll do 28 on paper here. So can I widen? I don't think I can widen this thing. So make it any bigger. Okay, it's okay with getting bigger, I guess. All right, so I'm going to go ahead. I want to do let's see, that was 26. So I'm going to do 28 right here. And then I'm also going to just do it on graphing. So h of x is equal to, and I've got x squared minus 36 and also x minus 11. Now I know that I can take the perfect, well, that is a difference of squares. I can take the square root of x squared, which is x, and the square root of 36, so it's x plus 6 times x minus 6, and just put the x minus 11 again. So if I do my little trick here, I'm going to set them all equal to 0. Ooh, I must have hit the little button on the side, so that's why it got a little blurry there. Let me erase some of that. Okay, that's a little better. So x minus 6 is equal to 0, and then x minus 11 is equal to 0. So you get your three answers right there. -6, +6, and +11. So let's go ahead and take a look at what that's going to look like. So notice -6, +6, and 11. That's what I'm expecting, and this is going to disappear, I believe. It does. But let me just kind of put it right here, and we'll see that again. So we had y is equal to x squared, and then we have minus 17x and plus 52. You know, this is the wrong one. Okay, hold on. I was all the way at this one. Okay, let's try that again. That was just going to be a normal parabola. So h of x, this is the one I was supposed to be at. X squared, and then I have a minus 36. That by itself would be a parabola, but then we also have x minus 11. Okay, I'm going to click the house, and then I'm going to zoom out a little bit. This looks really weird. So because it's so, it is going up, and then it turns around and goes back down. So that's what's happening. And I'm going to go ahead and click on these. Remember I said they were going to be -6. And y is something, oh, right here. Remember, if you hear me, or I made a little typo right there. So I hit a 2 instead of a 3. That'll change that. Now it's going to be what I expected. -6, +6, and then the other one was going to be 11. So that's exactly what I thought they would be right there. Okay, so let's do the very last one. And I'm not going to do that on factoring. We didn't really do that type in class notes. There's 4 terms right there. So I'm just going to type that one in. We've got y is equal to x to the third. Oop, I did it again. I meant a third. So look at the graph right now. So that's kind of an interesting graph. Then minus x squared. You'll see what it does there. It changed it a little bit. And then minus 9x. Now we have that kind of an S, sort of sideways S thing. And then plus 9 should just shift it all up. So, but we really only care about the intercepts there. So -3, +1, +3. -3, positive, wasn't there a 0? Oh, +3, I lost my track. 1 and 3. So 1 and 3. By the way, you could also pull up the table And anytime this is equal to 0, so notice they don't have negative 3 in there, so 3 is another 0, and so is negative 3. So you can see the zeros right here. That's a 0. I wish I could put in a highlighter here. So annotate. So this is a 0, this is a 0, and that's a 0. Okay? So when you're saying something is a 0, it's where the y value is equal to 0. All right. Believe it or not, I'm not sure if it is still recording. I don't see it anymore. So I may have to do this one again. But I'm going to try to find it, and we'll see. Oh, no, there it goes. Okay, so I'm going to clear that, close that off. I'm trying to get my controls. Okay. I'm kind of glad I can edit this, assuming it's... Let's see. Let's just square the screen, then move this out of the way, and I'm going to stop it right here.